All right, so 10.3 is dealing with a couple different things. We're going to be looking at angles in standard form and just kind of labeling some things. We're going to be drawing a little bit of angles or like sketching them, which is not too bad. We're going to talk about something called radians. Then we're going to look at going from degrees to radians and radians to degrees. Then we're going to look at a few different topics. So we're going to look at coterminal angles, reference angles, and then we're going to be looking at using or applying some of our trig functions to some of this. So this is going to be a big section. We may have to break it up depending on how quickly we get through everything in class. But I'm going to try to make this video as short as I can without leaving too much information out. So if you look over here, we've got a good visual representation of what we're going to be talking about here. So I'll try to use that as much as I can to help you see some of this. So first, we've got an angle on a coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So that's talking about this line here. That's talking about this right here. That's just saying when we have a ray where that happens, we have a standard form or we have an angle in standard form. So the ray in this instance is called the initial side. So this is the initial side. So that's like its start point because we're acting like we're starting at this initial side and then we're moving this ray here, we're moving that one or opening up or closing it, whatever you want to like use there. That one's the one that's actually doing the actual movement, but this initial side just stays. So that's going to be your x-axis always pretty much with how we're going to set these up. So this point here, or this line here, this ray is going to be our initial side. The other ray, which is the one, like I said, this one that's actually doing some of the movement here, it is the terminal side. So we have an initial side and a terminal side. The initial side is going to be on the x-axis, on the positive x-axis, and the terminal side is just going to be the one that opens up. All right, so if it opens up or rotates, we say here, or it says rotation here. So if it's a counterclockwise, which is, so a clock moves in this direction, a counterclockwise would be moving in that direction, similar to how you can see here, that's what's happening here. Those degrees or radians are going to be positive. So if it moves in a counterclockwise direction, we're going to have a positive angle measure. If it moves clockwise, which means if it moves, starts at this initial side and moves the opposite or the same way a clock would move, which is going this way, that would be negative, or it would result in negative angle measures. And then one full rotation is almost like a full circle. That's 360 degrees. So that's all our information we need to know there. Now, drawing or sketching these is just going to give us like an indicator of what I was talking about. So 75 degrees is a positive value, and we always start at this terminal or this initial side, which is on the x-axis, the positive x-axis here. So that's what our first ray is going to look like. And it's going to start, actually, I could probably draw it better. It's going to start here and then go this way. Now, this is going to open up 75 degrees, and it's going to go counterclockwise. So it's going to go this way, which 75 degrees would be about right there. And then our terminal side is just, it's just going to be wherever that 75 degrees is. That's where it opens up. So then our angle here would be right there, and that's what that would look like. Now, if we look at negative 160 degrees, now instead of moving counterclockwise, we're going to be moving clockwise because that value there is negative. So we're going to start at this initial side again, and we're going to move down and around pretty much. It's like we're going with the motion of a clock. we're going to be going to negative 160, which that would be right about here. Actually, I could make that a little bit better. So it would be right about there. So that's sort of how this sketch would look. Probably not precise, but 160 degrees. If you wanted to figure out where that actual degrees would be, so we would say 360 minus 160, and then that would be negative 160 would be at the same place as, what would that be? 200? Yeah. So that would be at the same place as 200 degrees, which is pretty much what that is right there. All right, so then our last one is 430. So these are a little bit weird. So that number is more than 360. So that means we're going to start at this initial side, and we're going to make a full rotation all the way around the, almost like it would be a circle. So all the way around would be 360 degrees. Then we would just need to know what was left over. So we could just say 430 minus 360 is equal to, what is that, 70? Yeah. So then this portion here would be approximately at 70 degrees if we were looking at it without the rotation. But you have to make sure that you go all the way around when you first start, and you're going counterclockwise because it's a positive number, and then you're going in a full rotation because it's more than 360 degrees, and then we're essentially just going where 430 would end up at the same place as 70 degrees. So that's just sketching these. Now, let's look at radians versus degrees. So a radian is a unit of angle measure based on arc length. So 1 radian is defined as the measure of the angle formed when the radius is equivalent to the length of the intercepted arc. So that's just a bunch of fancy language for what we'll get into to actually calculate these. So 360 degrees is 2 pi radians. So if you ever see 2 pi radians, that's telling you that that's 360 degrees. That means half of that would be 180. So half of 360 is 180. So half of 2 pi would just be pi. So 180 is equal to pi radians. And that's actually what we use to help us convert these. So when we're converting degrees to radians, radians is equal to degrees. So if we're given a degree, we're just saying degrees times pi over 180. So we'll look at some examples of that first. So like in number 4, we're given 30 degrees. So if we want to convert this to radians, we're going to say radians is equal to 30 times pi over 180. So that's the same thing as saying, and actually let me get rid of this and write it a little bit smaller. All right. So we've got 30 times pi over 180. And that is the same thing as saying 30 pi over 180. So we never, well, in some cases you may, but right now we're not going to actually be plugging in anything for pi. We're just going to leave it as pi. So all we need to know here is, what is 30 over 180? Does that reduce down to anything? And it would. It would reduce down to 1 over 6. So we're going to keep pi on the top. So it would be pi over 6. So 30 degrees in radians is pi over 6. Now let's look at 150. So we're going to do this the same way. If we have degrees, we're just going to say degrees times pi over 180 is going to be equal to radians. So we're going to take 150 degrees times pi over 180, which is going to end up giving us 150 pi over 180. And we're going to leave pi just as it is. So pi is probably going to stay on the top of our fraction. And then we're going to have a reduced fraction left over. So we'll have 150 over 180 reduces down to 5 over 6. So we'll have 5 pi over 6. And then a negative radian doesn't change anything. You still do the same thing, except your answer will just be negative. I'll do this one with you anyway. So negative 220, if we want to convert this to radians, times pi over 180 is going to give us negative 220 pi over 180. And then that's going to reduce down to negative 11 pi over 9. So essentially, like I said, you just take your actual numbers here. Don't worry about pi. Put those in your calculator and reduce it, or reduce it in your head, whatever. And then your answer will still have to be negative here since our degree was negative, but then pi stays in your answer. So you don't have to evaluate what pi is. You'll just leave it with pi in it. All right, so that's going from radians to degrees. Now, degrees to radians is just taking pi over 180 and flipping it. So if we have radians and we want to make that degrees, we're going to say 180 divided by pi is going to be multiplied by whatever radian we're given. And you'll see what ends up happening here. We actually have some stuff. We'll actually end up canceling out pi in every single one of these. So if we go to number 7, we've got 4 pi over 3. That's in radians. We want to convert it to degrees. So we're going to multiply this by 180 over pi. And you'll see here, we don't have any addition or subtraction going on in our numerators or denominators. So anything on the top and bottom of a fraction can cancel out. So this pi here and here will cancel out. And we'll be left with 4 times 180, which is 720, divided by 3, which is our the only thing we have left as our denominator. So 720 divided by 3 is 240. And this is degrees because we're going from radians to degrees. So then number 8, we're going to do the same thing. We're going to multiply. We have radians here. We're going to multiply by 180 over pi. And then our pi's will cancel out. And we'll have negative, because this negative here stays, 5 times 180, which is 900, divided by 36, which will give us negative 25 degrees. So anytime you have a negative radian or a negative degree and you're changing it to radians, is still, your answers should still be negative regardless. All right, then number 9, we've got 7 pi over 4. That's in radians. We want to convert it to degrees, so we're going to multiply by 180 over pi. Pi is going to cancel out, so 7 times 180 is going to be 1260 divided by 4, which is going to give us 315 degrees. So going from radians to degrees, or going from degrees to radians, you're going to say degrees times pi over 180. And then you're just going to pretty much simplify and reduce. Then going from radians to degrees, you're going to say radians times 180 over pi. Pi is going to end up canceling out, and then the rest is just simplifying. All right, so now the last parts of this will be a little bit tougher, but I don't think it'll be too bad. If we need to spend like an extra day on it, we will, because some of these can be a little bit confusing, I won't lie. So I'm going to try to keep everything in degrees for the most part, but we may have to look at some radian stuff too, but that's okay. We can deal with it. All right, so coterminal angles. So angles in standard forward position with the same terminal side are coterminal angles. So that just means that like if we were to look at, well, this is a good example here. So this is a good example right here. So negative 270 degrees and 90 degrees end up being the same exact looking angle, or they have the same terminal side, which is this y. So they end up in the same place. Meaning that if we were to make two separate graphs, two separate coordinate planes, 90 degrees would look like this, and then 100 or 270 degrees would look like this. It would look the exact same, except it did a full rotation almost, whereas 90 degrees just did a counterclockwise 90-degree rotation. So that's what that means when we're talking about coterminal. Essentially, more than one degrees can have the same terminal side. So You're going to give two coterminal angles for each given angle. One's going to be positive, one's going to be negative. So here's what we do here. So if your value is less than, I'm probably going to just keep these in degrees, and then we'll worry about radians and some of the other stuff. But I think for these, I'm just going to keep them in degrees. But we could also just convert them. But we're not going to worry about that. So looking at 10, if our value is less than 360, then all we have to do here is simply add 360 to 65 and then subtract 360 to 65. So the coterminal angles here would be, let's see, 65 plus 360 is 4. If I can delete that, there we go. 425. So 425 degrees and negative 295 degrees. So those are our two coterminal angles for 65 degrees. It's that simple. Now, if your degrees that you begin with is more than 360, we've got to do something a little different here. So we've got to actually start off by subtracting. So we're going to say 540 minus 360. That's going to be our first coterminal angle, which would be 180 degrees. Now, instead of using this 540 and adding 360 to it, we're going to use this coterminal angle and find we're going to subtract 360 from that. So if you have a angle measure greater than 360 degrees, the first thing you're going to do is subtract by 360, and then the angle that you get from that, which is 180 degrees, we're going to subtract that by 360. So that's going to give us negative 180 degrees. So our coterminal angles here would be 180 degrees and negative 180 degrees. Now, we could do this portion here with the radians because we know that 360 is equal to 2 pi. So 360 is equal to 2 pi. So we could actually just sit here and say, we could subtract this by 2 pi and add 2 pi to it because 2 pi is the same thing as 360. I'm just not going to make you do all of that. So we're going to leave that part out. But that's how you do it. If you see it in the future, it's not too bad. So that's coterminal angles. And I'm going to try to go back over this in class because I know it may be a little bit confusing. Next, we have a reference angle. So for an angle theta in standard form, the reference angle is the positive acute angle formed by the terminal side and the x-axis. So if we go over here, we have a good look at that. So here we have a coordinate plane, and our terminal or our initial side is here. Our terminal side is here. It's just saying it opened up however many degrees that is. So however many degrees that is there, which is theta, that's how much it opened up. Now, we don't care about this angle here. We care about the angle that is formed with the terminal side and the x-axis. So that would be this shaded part here. So like if we were looking at, let's see, if we were looking at 225, that would look somewhat like this. These don't have to be exact. We can sketch it. So 225, if this were to open up in a straight line, this would be 180. So it's going to have to be over or past that. So it's positive. So it's going to open up counterclockwise, and it would end up being about right there. So that's what our angle would look like. Now, we don't care about this angle here. We don't care about this full angle. We care about the angle that is formed from the x-axis, which is here, and this terminal side. So we care about this shaded part there. We want to know what that is. Now, that wouldn't be too hard to find because we just would have to take 225 minus 180 because that's a straight line, and we would figure out what that is. Because 180 would be whatever's left over after we subtract out this value here, which would be 180. That would be whatever's left over. So we would say 225 minus 180. that's going to give us 45 degrees, which hopefully when we do some of this in class, it'll look a bit easier. While we're on the videos, it's not as easy to see, but essentially we have 180 degrees involved or within this 120 or 225. So if we subtract it out, whatever's left over would be this shaded area here. All right, so then we'll look at 15. So 15, we've got negative 310, and so that means we're going to have to start off, that's a negative number, so if we want to sketch this, we're going to have to start off at our initial side, which would be here, and we're going to have to go clockwise 310 degrees, so that would end up about right here. So then what we're concerned about is not this actual area or this measure. We're concerned about this measure, this shaded area here. So all we have to do here, if this were to completely go around, it would be 360 degrees. So if we want to figure out what that is, we can just take 3 or negative, well, you could do it one of two ways. You could either say 360 minus that 310, or you could say negative 310 plus 360. It doesn't matter. So we just want to figure out that gap. So if this complete rotation would be 360, we want to then take this 310 out of it, and that will tell us whatever is left over here. So if we take 360 and subtract 310 from it, we'll get 50 degrees. So 50 degrees is what our measure would be here. Our angle measure would be here. All right, so then on 16 we have radians. We're going to look at that, but I think I'm going to probably leave that part off of the homework. But we could do this still. We'll get into the unit circle, so you would be able to do this a lot easier probably once we've done that. But here, it wouldn't be too bad. So we could just actually convert this to degrees. So if we want to go from degrees to radians, we'd take 180 divided by pi and multiply it. Then pi would cancel out. We would end up with 2 times 180, which is 360. And then we would have 360 divided by 3, and that would be 120. So this is actually 120 degrees. So 2 pi over 3 is 120 degrees. So that's a positive number, so we're going to start out at this initial side. And we're going to open up counterclockwise to 120, which would be right about there. It would be in between 180 and 90 degrees. So we don't care about what is actually formed here. We care about what's formed with the terminal side and the nearest x-axis, which that would be here. So we care about the acute angle, so we want to know what that is. So for this, it wouldn't be too hard. If we were to end up going completely to this side, it would be a straight line, and a straight line is 180 degrees. So we can just take 180 degrees and subtract it by what we have, and what's left over will be actually that angle. So that will be 60 degrees. Now, if we wanted our answer in radians, all we would have to do is take degrees and take 60 degrees and convert it into radians. So that would look like this. It would be 60 times, for some reason my doesn't want to work. Okay, there we go. 60 times pi over 180, which is going to give us 60 pi over 180. And then we just reduce 60 over 180, which will be 1 over 3, which is pi over 3. So that's how you deal with radians when you're looking at reference angles. And we'll probably go back over this in class because I know that this may be a little bit confusing on the video with how I have to explain some of it. But the last part is probably... I don't know. It's not too bad. Once you actually get this down, it's not too bad. But at first, it's a little weird. So trig functions here. So if we let theta, which we're looking, or we're basing it off of this. So when I'm talking about each part, you can reference that to see it. So when we're looking at theta, which is here, that angle there, in standard form, we've got a point X and Y, which is here, which is this point. If I can do it, please go away. It would be that point there. We can let that be a point, and it's on the terminal side of theta. The distance from that P, or that point, to the origin, which is here, so that distance, R, can be found using the Pythagorean theorem, except we're just going to change how it looks. Instead of saying a squared, we're going to say x squared. Instead of saying b squared, we're going to say y squared is equal to r squared. So that means the two coordinates that we have, x and y, are x and y squared here, and then r is whatever we get after that. Then we can set up sine, cosine, tangent, cosecant, secant, cotangent, because here's what ends up happening. If you look here, we end up having a triangle formed. So I'm going to get rid of everything. We have a triangle formed here, and y and x are our two legs. Our hypotenuse is r. So if we set up our trig ratios, it'll work the same way, because theta would tell us where to, pretty much where to go. So if theta is here, and we want to look for sine, we're looking at opposite over hypotenuse. So opposite of that would be y, and hypotenuse would be r. So we would have y over r. Then cosine would be adjacent over hypotenuse. So the adjacent side would be x, and the hypotenuse would be r. Then for tangent, it would be opposite over adjacent. So opposite would be y, adjacent would be x. So we would have y over x. And you could actually just memorize these if you wanted to, and it'll make life easier on you. But you don't have to, because we can just go through this same step with, I'll show you on the example that we're going to look at. So then cosecant is just the opposite of that. I'm probably not going to make you worry about that, but I might, just to refresh your memory. So cosecant is just the opposite of, or the reciprocal of sine. So if sine is y over r, cosecant is r over y. Same thing for secant. It's just the reciprocal of cosine. So it's going to be r over x. And then cotangent is just the opposite of tangent, or the reciprocal. So it's going to be x over y. All right, now we're going to look at an example of doing this, because I know that's probably a little bit confusing. So we've got a point 5, negative 2. So the first thing you're going to do is plot that, because it's going to be a point on your terminal side of theta. So your initial side is always going to start from the origin and be positive on the x-axis. Now, 5 over 2, this may not be exact, but we don't need it to be. That's going to be, let's see, up 5, or over 5. So 1, 2, 3, 4, 5. And then up negative 2. So, or down negative 2. So 1, 2. Actually, I went the wrong way. I went negative 5. It'd be 1, 2, 3, 4, 5. All right, and then down 2. So it would be right there. So that means that our terminal side goes through that. So then we can make a triangle based upon this. So your triangle is just going to be, it's going to connect to, from your terminal side and just go straight up to your x-axis. Or like say that it were here, our triangle would be there. And if it went, like say it went down here, your triangle would be there. Pretty much it's like using your reference angle. So our triangle here would look like this. I'll try to draw it in a different color. This would be our triangle. Triangle would be that there. And we know that this side is equal to 5 because that was the distance there. And then our height here, which is this point, would be equal to negative 2. Or it would just be 2 since it's distance. So then we've got to figure out what our hypotenuse is here, which our hypotenuse would be this side here. So we're going to figure that out by using x squared plus y squared is equal to r squared. So we actually may not even have had to have drawn that. I just drew it just so you could see it. So x squared is going to be 2. So we're going to say, actually, x squared is going to be 5. So 5 squared plus 2 squared is going to equal r squared. So that's going to be 25 plus 4 equal to r squared. So then 29 equals r squared. So then r equals the square root of 29. So our radius here, or our hypotenuse here, is r is equal to the square root of 29. Now we can use what we know about x, y, and r and just set up these ratios here. So we'll do that. So we've got, if I were you, I would do this. I would just come off to the side and say x is equal to 5 because that's our x coordinate here. Y is equal to -2 because that's our y coordinate here. And then we found r was equal to the square root of 29. And then we're just going to set up each of these ratios. So the first one for sine is going to be y over r. So y over r is going to be negative, let's see, that'd be -2 over the square root of 29. The only problem with that is we can't leave it as the square root of 29. We can't leave the square root of 29 on the bottom, so we have to rationalize this by multiplying the square root of 29 on the top and bottom. So we'll end up with -2 square root of 29 over 29. And then cosine is going to be x over r. So x is 5. R is the square root of 29. So we're going to have 5 over the square root of 29. And then we have to rationalize this because we can't have that square root of 29 on the bottom. So then we'll get 5 square root 29 over 29. All right, then tangent is y over x. So y over x. So we'll have, let's see, y is -2, x is 5. So we'll have -2 over 5. And then for cosecant, secant, and cotangent, we just take sine for cosecant and flip it. So we'll take, and we're actually going to take this portion here. Don't take what you've already done there. Take this portion here and flip it. So we're going to take -2 over the square root of 29 and flip that. So it'll be negative, or the square root of negative square root of 29 over 2. Let's see, when we flip cosine, it will be, use this. Don't use what you did at the end. Use what you did at the start. So we'll take 5 over the square root of 29 and flip that. It'll be the square root of 29 over 5. And then when we take tangent and flip that, it would just be 5 over 2, and it would be negative. So we're probably going to have to work back through some of this because I know this is a long video and a lot to cover. But try to work back through this. If you can, it'll help you understand this. And we'll go over it a little bit in class. But that's going to be it for this video.